Training in Weld Quality Assurance and Quality Control. Section 6. Non-Destructive Testing. Topic 2. Principles of Visual Testing. The objective of this topic is to be able to identify the basic principles and applications of visual testing. Visual testing is by far the most popular and widely used method of non-destructive testing. It consists of examining welds and overall weldments by eye and comparing the evaluations to a set of standards. Among its many advantages are that it is the least expensive of the various inspection methods, requiring little investment in tools and equipment, and it usually takes less time to perform. Correctly applied, it is an effective quality control method which can ensure conformity to procedures and allows potential errors to be corrected. This in turn leads to higher quality weldments at lower cost. Visual inspection practice requires the inspector to be familiar with all duties which apply to inspection, such as learning to read drawings, having a knowledge of welding processes, familiarization with specifications and procedures, and the use of workmanship standards. The inspector must be capable of making responsible judgments, accurately recording data, and writing concise reports. Although visual testing is the simplest method to perform, it is good practice to establish detailed written procedures to ensure proper application of the inspection. The first area of visual inspection takes place before welding and is likely the most important. Proper inspection prior to welding can eliminate errors which lead to costly defects in the welds or weldment. The first step for the inspector is becoming familiar with all aspects of the job, such as material specifications, the bill of materials, and the welding procedure. When completely familiar with all the written details, the dimensions are compared to the engineering drawings to verify that all parts are within tolerances. Improperly dimensioned subassemblies lead to difficulties in the final fit-up of the weldment. Next, the joint preparation is examined, and the surface conditions of the material is checked for proper cleaning and lack of flaws. Poor fit-up, contaminated base metal surfaces, improper equipment and settings can lead to weld discontinuities or defects. If backing is specified, it should be in accordance with job specifications and securely fastened in its proper location. Verify that the tack welding procedure and the tack welder qualifications meet the code or standards requirements. Tack welds must be checked closely since they become part of the finished weld and should meet the same soundness requirements. Pre-weld visual inspection also includes examining the equipment, power sources, fixtures, clamps, and so forth to ensure proper operating condition. The second area of visual testing takes place during the welding operation. In-process visual inspection begins with verifying that the specified procedures are being followed correctly. Observing the welds during production can help eliminate costly repairs by catching problems before completing the welds. The inspector will also be observing welder skill, verifying that proper interpass temperatures are maintained, and assuring that cleaning requirements have been met. In-process inspection might also include comparing each pass or layer to a sample workmanship standard. The third area of visual testing consists of examining the finished welds or weldments and comparing them to engineering drawings or specifications. This assures proper part dimensions, weld size and location, and assures that the correct amount of welds are placed on the weldment. Tools are available to measure weld size, such as this set of fillet weld gauges, which can check whether or not the weld has the correct leg length or throat. Here's an example of a high-low gauge measuring face reinforcement on a groove weld. The difference in height between the reinforcement and the base metal is indicated by a scale built into the tool. This gauge may also be used to check the alignment of parts prior to and during welding, as well as after. Examination of the weld surface itself is another part of post-weld inspection. Common discontinuities visible to the surface could be cracks, porosity, undercut, overlap, arc strikes, and excessive spatter, to name a few. Each of these will have detailed allowable limits based on codes or inspection procedures. After welding examination may also reveal base metal defects, such as delaminations, cracking, or excessive distortion, all of which should be clearly marked for repair. Once all aspects of before, during, and after welding inspection have taken place, we must then look at the documentation of visual testing results. The inspector thoroughly and accurately evaluates the results to decide whether or not the welds and weldments meet prescribed specifications. Once all the areas mentioned have been completely inspected, the inspector then makes reports of every detail and keeps complete records. Here, any items which do not meet the requirements are noted and described. If any repairs were made during production, this is also reported. Good record keeping is essential. Whenever such details are required, they are normally signed or certified by the fabricator, with copies made for all personnel involved. Visual testing is an invaluable quality control technique. However, caution must be taken with evaluating. Welds with good surface appearances are often good quality, but appearance alone will not prove that careful workmanship took place throughout the entire process. All phases of visual inspection discussed must be performed to be confident of required weld quality.